Alright, so in this video we are going to be doing an example of a one-tailed t-test, or z-test, I'm sorry. So we're going to do a one-tailed test. So our problem for this particular example is, according to the National Center of Health Statistics, the mean weight for an adult female in the United States is 164.7 pounds. A group promoting healthier eating habits feels strongly that it has made an impact on one community by reducing the mean weight of women in that community to below the national mean. So basically they've done subtype of treatment in which they are promoting healthier eating, whether that's through advertisement or maybe they have clinics going on, things of that nature. So they've done something to this one community and they think that that's impacted the weight of the women in that community. So they have a simple random sample of 39 women in this community, has a mean weight of 161.8 pounds. So we're assuming that the population standard deviation is 5.6 pounds. Is there sufficient evidence at the 0.01 level of significance to say that the mean weight of women in this community is lower than 164.7 pounds? Again, that's our national average. So the first thing we want to do is state the hypothesis. The big key here is in that very last sentence where we said, just really right here at the end where it says that they want to say that the mean weight of the women in the community is lower than 164 pounds. So notice we are giving a very clear direction. We want it to be lower than the national average. Okay, so we want, again, lower than the population or lower than the national average. So because of that, we're going to do that one-tailed test. Remember, anytime we do a directional, anytime we say direction lower than or greater than, that automatically narrows us down to that one-tailed test. And we're going to do our two hypotheses. I, again, always like to start with the alternative hypothesis when we're doing a one-tailed test. So we would do the alternative hypothesis is that mu is less than 164.7. So again, remember, because we want to be lower than that. So we're saying that our population is going to be lower than 164.7. And then we go back and do the null hypothesis, which is exactly the opposite. So for our alternative was less than, then that means our null hypothesis would be greater than or equal to. Again, when you're doing that null hypothesis, you always need to make sure you do the or equal to. So now let's determine our critical region. Again, this is the same chart that we had in the previous video for our two-tailed test. This time we are using an alpha level of 0.01 and we're doing a one-tailed test. So that means that our critical region, our critical score, is going to be 2.33, and it's actually going to be a negative 2.33 since we are looking at things being lower than our mean. So we're looking at our negative side of our graph. So again, if anything falls below negative 2.33, we would reject our null hypothesis, basically saying, yes, we think that there is a difference between our community and the national average. And then conversely, if anything falls above that negative 2.3 z-score, we would fail to reject that at that point, and we would say, no, we don't think that there's a difference between this community and the national average. So let's go to computing our z-score. Okay, so again, we're going to use that same z-score for our sample mean. So the first thing we need to compute is our estimated error. Again, the two pieces of information we need that sample size of 39, and we need that standard deviation of 5.6 pounds. So we have 5.6 divided by the square root of 39, which would give us 0.8967. All right, now we're going to do our z-score. So that, remember, the two pieces of information we need for our z-score, in addition to our standard error we just computed, is we need our mean of our population. We need the mean of our sample. So starting off with the mean of our sample, that would be the weight of 161.8 pounds. And then the mean or the average of our, according to the National Health Center, the mean for the adults in the U.S. would be our population, 164.7. So now calculating our z-score, 161.8 minus 164.7 divided by that standard error, So now we have negative 2.9 divided by 0.8967, and we end up getting negative 3.23 as our z-score. So now again, the last thing we're going to do is we've got to make that decision. Are we going to reject the null hypothesis, or are we going to fail to reject the whole null hypothesis? So remember from our step 2, when we figured out our critical region, we said that anything that fell below negative 2.33 fell inside of our critical region, and therefore we would reject. So our z-score from step 3, we found negative 3.23. That is clearly smaller or less than our critical region. So it is falling inside of that area where we say, yeah, we're going to reject the null hypothesis. This is a significant difference. And so what we would say is, at a 0.01 significance level, there is sufficient evidence to support the claim that the average weight of women in this community is lower than the national average of 164.7 pounds. So we've shown something's made a difference in this community as far as the weight levels of the women. Now, this is kind of considered a quasi-experiment because there are so many factors going into this. We'd really have to look at the things impacting this community to see if it was truly the part of that particular organization trying to promote healthy eating, or was there something else going on inside of that? But at least we do know that there is some type of difference here between the community and the national average.